Section 8.2 is about the properties of parallelograms. So what we're going to get into now is all the different kinds of quadrilaterals, starting with parallelograms. So let's first define what it is. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So if you're looking at this diagram, notice that we have these two sides are parallel and these two sides are parallel. So by definition, this would be a parallelogram. All that it takes to be a parallelogram, so you see the word parallels inside of there, all that it takes to be a parallelogram is that the opposite sides of a four-sided figure have to be parallel. The symbol for a parallelogram just looks like a parallelogram. And by definition, again, referring to this diagram, since we know that opposite sides are parallel, we would know that QR is parallel to PS, and we would also know that QP is parallel to RS. So just to reiterate, all that it takes for a four-sided figure, a quadrilateral, to be a parallelogram is that both pairs of opposite sides have to be parallel. As long as both pairs of opposite sides are parallel, it is a parallelogram. So stemming from the definition of parallelograms, we come to two theorems. Theorem 8.3, if a quadrilateral is a parallelogram. So again, just by knowing something's a parallelogram, we know that opposite sides are parallel. Then its opposite sides are congruent. So as long as you know something is a parallelogram, then you know that opposite sides are congruent. So QP would be congruent to RS, and QR would be congruent to PS. The second theorem is theorem 8.4. If a quadrilateral is a parallelogram, so again, if you're told that something's a parallelogram, then its opposite angles are congruent. So you would know that angle Q is congruent to angle S, and angle P is congruent to angle R. So there's lots of different things that you now know based on just being told that something's a parallelogram. You know that opposite sides are parallel, and you know opposite sides are congruent, and now you also know that opposite angles are congruent. So now let's put those theorems to work. Example number 1, find the values of x and y. So we know that this is a parallelogram because we see that this side is parallel to this side and this side is parallel to this side. So knowing that this is a parallelogram, we can now apply those theorems on the previous slide. We know that opposite angles are congruent. So if this angle H is 72, then angle F would also be 72 degrees. So x would equal 72. And again, since this is a parallelogram, we know that opposite sides are also congruent. So if this is y minus 8 up here, and this is 36, then we would know that y minus 8 is equal to 36. So this is just as simple as adding 8 to both sides and solving for y. So y would equal 44. So x equals 72, y equals 44. And now we have a third theorem, theorem 8.5. If a quadrilateral is a parallelogram, so again, if you're told that something's a parallelogram, then its consecutive angles are supplementary. So not only do we know that opposite angles are congruent, now according to this theorem, consecutive angles are supplementary. So remember, supplementary angles add up to 180. What it means by consecutive angles is angles that are on the same side. So x and y here, or x and y here, or x and y here. So not across from each other, but rather kind of like on top of each other or sitting next to each other. So consecutive angles are supplementary. So for example, if I knew that x was 110 degrees right here, not only do I now know that this is 110, but I also can figure out that both y values would be 70, since we know that consecutive angles are supplementary, since 110 plus 70 is 180. So let's use that theorem here in example number 2. It says a metal screen is used to cover a shop window when the shop is closed. The sections of the screen are parallelograms. If the measure of angle LMN, so that's this angle right here, is 110 degrees, so let's mark it 110 degrees. What is the measure of angle MNO? So if this is a parallelogram right here, the measure of angle MNO is the angle that we're looking for. That would be a consecutive angle with the angle we were given, angle LMN. So if it is 110 degrees, then I'm just going to do 180 minus 110 to get the measure of angle MNO to be 70 degrees. Again, I did 180 minus 110 that was given to get that 70 degrees. And now we have our fourth and final theorem about parallelograms. If a quadrilateral is a parallelogram, so again, if you're told that it is a parallelogram, then its diagonals bisect each other. So let's dissect what this is saying. The diagonals means that I'm going from one vertex to the opposite vertex. That's the diagonal. So QS is a diagonal and PR is a diagonal. The diagonals bisect each other. Remember, bisecting means that they cut each other exactly in half. So that would mean that this point M, where they intersect, would be the midpoint of QS and of PR. So that QM and SM are congruent, and PM and RM are congruent. So we know lots of different things about parallelograms. Let's write these down to summarize it. So by just being told that a quadrilateral is a parallelogram, you know these 5 things. You know that opposite sides are parallel. That's just the basic definition of what a parallelogram is. You also know that opposite sides are congruent. You know that opposite angles are congruent. You know that consecutive angles are supplementary. And then finally, we know that the diagonals bisect each other. So again, just by being told that something's a parallelogram, we know all of these 5 things. I would write this down in your notes and star it, highlight it, whatever you need to do, so that you know every time you're told that something's a parallelogram, these are the 5 things that you can assume. And now on to example number 3. The diagonals of quadrilateral PQRS intersect at point T. What are the coordinates of point T? So the first thing that we need to realize is that PQRS is a parallelogram because QR would be parallel to PS since they both have a slope of 0. Horizontal lines have slopes of 0. PQ would be parallel to SR because they both have a slope of 3/2. Notice I go up 1, 2, 3, and over 2. From here I go up 1, 2, 3, and over 2. So now I have 2 pairs of opposite sides that are parallel, making, again, PQRS a parallelogram. So knowing now that PQRS is a parallelogram, from the last theorem we know that the diagonals of a parallelogram bisect each other. So that means that point T is the midpoint of PR, and it's also the midpoint of QS. So at this point, these are the things that we know. We know that PQRS is a parallelogram, and we know that the diagonals bisect each other, making point T the midpoint of both QS and PR. So what we can do is use the midpoint formula to figure out the coordinates of point T. So again, you could either use the coordinates of P and R to find the midpoint T, or the coordinates of Q and S to find the midpoint T. Let's just use P and R. So the point at P would be 2, 1. And the point at R would be 9, 4. And remember, the midpoint formula, all you're going to do is add the x's together, divide by 2, and add the y's together, divide by 2. So doing so, to find point T, we're going to add the x's together, 2 plus 9, and divide by 2. Then we're going to add the y's together, 1 plus 4, and divide by 2. So that means that T is at, well, that'd be 11/2, which is 5.5. And then it would be 5/2, which is 2.5. So the coordinates of point T, again, the midpoint of PR or QS, depending on whichever one you want to do, would be at 5.5 and 2.5. So that's it for this section. Make sure you jot down anything you didn't understand that we can cover in class, and we can cover that before we move on, and we'll see you then.